So in the last experiment, we want to illustrate the potential of opening the interface between the SSD and the application. The general idea is that if the application can pass information to the SSD could then use this information to improve performance. In this experiment, we allow the application to communicate to the SSD which pages are likely to be deleted at the same time. The SSD can then write these pages onto the same blocks on flash. When these pages die, entire blocks become invalid at the same time, and so we can erase them without performing any migrations. This greatly cheapens garbage collection. So for these experiments, we run a file system-like workload. So each file spans multiple flash pages, and when a file is deleted, all these pages become invalid at the same time. So to illustrate, the difference between the two runs we'll have is in the first run, different files, the colors represent different files, and different pages from different files will be mixed on the same physical blocks. Whereas in the second run, files will be separated on different blocks. Okay, so now let's see what the performance looks like. So we now run it without tagging, and I should note that we calibrated the SSDs for both runs using the same workload that was used for the actual experiment. Okay, so here we see that the key thing to notice here is that is the number of garbage collection operations, because these reflect the number of migrations that took place. And here we see that the number is approximately 70,000, and the throughput was around 13,000 IOs per second. Alright, and you can also try to recall the write characteristics. There were no reads in this experiment. Okay, so now we try the second approach, and notice that we're now using an allocation strategy where we try to exploit locality and where the application communicates locality. Okay, so let's run this. And still working. Okay, so now that it's finished, we see that the number of migrations that took place here is significantly lower. Here it's below 40,000, and before it was around 70,000. Moreover, throughput jumped from 13,000 IOs per second to 16,000 IOs per second. And so we managed to boost performance quite dramatically using this open interface extension. So to conclude, I hope that I've managed to give a good impression of EagleTree as a platform on which comprehensive experiments can be made on SSDs in a tractable way. And I hope that I've also given a few glimpses and insights about how SSDs work and how we could in the future leverage an open interface yes.